topic for the day is binomial theorem. Let's begin with a question. Why the name binomial? Binomial means a simplified algebraic expression of the sum or difference of two terms. For example, it can be 3x minus 4y, y plus 3x. Now our topic is how to expand these expressions when you have it in the form a minus b to the power of 10, or let it be y plus 3x to the power of 20, or y plus 3x to the power of 8. So how are we going to expand these terms? This is what we are going to focus on for the day. Let's see the prior knowledge that we require to move ahead. What is NCR? Now the combination of terms when you have NCR is given by NCR equal to n factorial over r factorial times n minus r factorial. Let's find the value of 5z0, which is equal to 1, 5c1 equal to 5, 5c5 equal to 1, 5c4 is equal to 5. Again, a very quick recap for those who need a brush up here. Now 5 factorial means you multiply 1 times 2 times 3 times 4 times 5. So if it's 3 factorial, it just means 1 times 2 times 3. So this is the meaning of the factorial of each term. And if you have 5c4, which means it's going to be applying this formula there. Your n is 5, so 5 factorial over 4 factorial, because r is 4, and within brackets 5 minus 4 factorial. Now 5 factorial is 1 times 2 times 3 times 4 times 5 divided by 4 factorial. So you have 1 times 2 times 3 times 4 multiplied by 5 minus 4 is 1 factorial, so it's just 1. Now what you can see here is that you can cancel these terms and what remains is a 5. So that's the explanation for this. Let me also show you in terms of n, and n will be based on the question. Now when you have questions like expand the following, a plus b the whole power 2, this is quite familiar and easy. You can do it by expanding term by term. Either you just split it as a plus b times a plus b and then you just expand the terms. You can do it pretty quickly and you can get the answer as a square plus 2ab plus b square. Similarly, if it is a plus b the whole cube, you have a cube plus 3a square b plus 3ab square plus b cube when you expand it. Now you can see that the numerical coefficients for a square here is 1, for ab is 2, and for b square is again 1. When it comes to a plus b the whole cube, the numerical coefficient for a cube is 1, for a square b is 3, ab square is 3 again, and for b cube it is 1. Now let's see what is the link that the Pascal's triangle got to do with the binomial term expansion. Now let's identify a pattern here. If you look at this too, it's the sum of the previous terms. Can you see here? Now when you look at these two, you get a 3 when you add 1 plus 2. And again the 3 here, it's 1 plus 2. So what will be the terms here? It's going to be 4 because I'm adding 1 and 3. Here I'm going to add 3 plus 3, it's going to be 6. 3 plus 1, which is going to be 4. Coming down the pyramid, I have 4 plus 1, which is 5. And here it's going to be 10, again 10 and 5. Now if you complete the pattern, you can see a triangle being formed with all ones at two sides and the middle values are being the sum of the previous terms added together. Now let's look at the power expansions. A plus b to the power 0 is just 1. A plus b to the power 1 is 1a plus 1b. A plus b the whole power 2 is 1a square plus 2ab plus 1b square. A plus b the whole cube equals 1a cube plus 3a square b plus 3ab square. And a plus b the whole power 4 is 1a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus 1b to the power 4. Now if you look at the coefficients in red, this is exactly what you see in a Pascal's triangle. So you can see that you can get the coefficients at each level. So this is going to be when the power is 0, and you have here when the power is 1, and this is the coefficients when you have the power 2, 3, and so on. So using the Pascal's triangle, you can find the numerical coefficients for each term in a binomial expansion. And the second thing is that if the power is n, for example, if it is a plus b to the power n, you will have n plus 1 terms in the expansion. For example, a plus b, the whole power 3. So your n here is 3. You have 1, 2, 3, 4. So 4 terms, which means you have n plus 1 terms. Like here you have n2, so you have 1, 2, 3 terms. So a plus b the whole power n, you will have n plus 1 terms. Now the third thing that you can realize is that these numbers can be written as combinations. Now this row can be written as the power n is 2, so I'll write 2c0. Then you have 2 can be written as 2c1, and here again 2c2. For a plus b the whole cube, this is going to be 3c0. Here it's going to be 3c1 because the coefficient here is 3. Now this is going to be 3c2, and finally here this is 3c3. Talking about the last one, again this is going to be 4c0. So you have 4c1, 4c2, 4 here, so it's 4c3, and last one is 4c4. Sharing the binomial theorem with you here, can you see that it shows a plus x to the power of n is equal to nc0 a to the power of n plus nc1 a to the power of n minus 1 times x plus, and each term is getting added up for the final expanded form. And you can see it's also equal to sigma r equals 0 to n ncr a n minus r x to the power r. Let me just write it neatly, or maybe a bit bigger, so that you can see this. Now let me make it easier for you by showing you how to expand. Find the terms in the binomial expansion of x plus 2 to the power 5. So first thing, here n is equal to 5. That means you're going to have n plus 1, 6 terms. So first I'll write the coefficients as I showed earlier. So here it's 5, so the first coefficient will be 5c0. Then you can see it becomes 5c1, 5c2, 5c3, 5c4, and 5c5. So that is done. The term 1 takes the highest power and then it reduces till 0. So here the highest power is 5, so I'll start writing it as x to the power 5, then x to the power 4, x to the power 3, x to the power 2, x to the power 1, and the last term will have x to the power 0. Now to include 2, 2 takes the lowest power from starting from 0 to an increasing power till 5. So I will write 2 to the power 0, 2 to the power 1, 2, 3, 4, and 5. So that's it, your expansion is complete. Just repeating the process. Remember the power of x, it starts from 5 and falls up to 0. And the power of 2, it increases from 0 and it goes up to 5. And then you put the coefficients. You can also use your Pascal's triangle where you have 5, so this is going to be the values. So here you have 1 times x to the power 5 times 2 to the power 0 is again 1. So x times 5 plus you have 5c1, which is 5. So 5 multiplied by x to the power 4 times 2 plus you have 5c2. 5c2 is 10. So 10 times x cubed times 2 square is going to be 4 plus 5c3. 5c3 is again 10. So 10 times x squared times 2 cube is going to be 8 plus, I'm just writing it below, 5c4 is 5. So 5 times x times 2 to the power 4, which is 16, plus 5c5 is 1. So 1 times x to the power 0 is 1, and times 2 to the power 5 is going to be 32. So my final answer will look like x to the power 5 plus 10 x to the power 4 plus 40 x to the power 3 plus 80 x to the power 2 plus 80x plus 32. Now let's try doing the next one. You can always pause the video and do it by yourself and then check for the answer. Following the same steps,